Sure. So Travis Spencer is my name. I'm an American living in Sweden. I moved there in 2010 when I started Twobo Technologies, and my background is computer science by training. I've been a software engineer for a little over a decade. I worked initially in broadcast, like Asborn, but for Technicolor and Thompson Grass Valley. And in 2008, I went into banking, as all the banks were getting bought up and failing, which was sort of a bold move, but it was actually fortuitous because as banks tried to put themselves together, what they found was a main impediment was digital identity. And they stuck me in a room with a really sharp team of people and said, figure out this whole identity thing, and this group over here is going to do the online banking thing. So we just sort of nestled up together and figured it out after a couple of years. And then when I moved to Sweden in 2010 and founded Twobo Technologies, the company's entire mission is to help other organizations who are struggling with digital identity. So that's a little bit about myself. In addition to founding Twobo Technologies, in 2013, I also started Nordic APIs together with my colleagues at Twobo. And this, as was said at the beginning, is really a community to help others understand more about APIs. At Twobo, we're very, very focused on the security of APIs, and there's a lot more to it, as you just heard from Asborn. So we need help from others within this community to tell the whole story. And so we have a blog, and we have a YouTube channel, and we have various resources like ebooks that are all freely available for you to go there and learn about the marketing, business models, design, operating your API, that sort of thing. So be sure and check that out and join the community and take part. But for today, what I'm going to talk about is API security. That's really what we are passionate about at Twobo. And thankfully, it's not going to be a long talk, and we'll have lots of time for questions, actually, because API security is a solved problem. We just use API keys, right? I was at the hotel last night, and to secure my room, I just need a key, right? So I need a hotel key. To secure my car, I just need a car key. To secure my house, I just need a house key. So if I'm going to secure my API, I just need an API key, right? Unfortunately, it's not that simple. Because what is an API key? It's a revocable, unaudience, non-expiring bearer access token. That's kind of geeky. It's a symmetric key. Still a little geeky. It's a password. So API key is a password. And I struggle with passwords. I hate them. I mean, even with a password manager, it's still sort of a pain. So we're going to build all these APIs and do all these great things with APIs, and we're going to start with a broken system. We need something better. So when I travel around and I meet people and I talk with customers, sometimes I hear this, okay, API security, we'll just do OAuth instead. Problem solved. Yeah, that's part of the solution, but that's not the whole thing. I wish it were that simple, and we're going to talk a lot about OAuth today, but there's a lot more to it. We need to look at the whole picture. We need to think about protecting the computers on which our APIs run. We need to make sure that the endpoints, the mobile devices that are being used to access our information are also safe and secure. And of course, we need to secure the APIs. So if you take that whole thing together, then we have a comprehensive solution for protecting our data. And what's interesting about that is that if you look at those different aspects, enterprise security, API security, and the endpoint security, or mobile security, right there in the middle of all of that is identity. Basically, who's at the other end of the API? Who am I talking to? I mean, when I got here, I recognized a gentleman that I met many years ago. I mean, as people, we are relational beings. We want to know, we want to understand, we want to meet, we want to create relationships. So identity is just normal for us. But for a computer that only understands a 0 and a 1, it's not in its nature. So we have to find a way to digitally encode identities within these systems that we're building. And thankfully, these days, we have extremely good ways of doing this. In the Years bygone, we had other systems that were actually inferior to what it is we have today. So today we have a stack of different suites or different protocols that we can put together to figure out who's at the other end of that API. And those standards we call the Neo Security Stack or New Security Stack. And so for authentication, we can use Web Crypto and U2F. And for provisioning, like creating user accounts, updating them, deleting them, we can use a protocol called SCIM, or System for Cross-Domain Identity Management. For actually representing those identities, we want to encode in them and have some sort of format about like your shoe size and your hair color and things like that. For that, we have the JSON Identity Suite. We want to be able to take the answer of who you are in one security domain and reuse that in another. In other words, we want to use federation. To do that, we have OpenID Connect. And we want to delegate access. I want someone else to be able to do something on my behalf. I want some application to do something for me on my behalf. I want to allow one application to do something for another application. Those are delegation problems, and those are encoded into the OAuth 2 protocol. We've never had a protocol that was so easy for doing delegation, even though that's been such a large problem for so long. And of course, after we figure out who somebody is using all of these different protocols, we need to figure out the more important question of what they're allowed to do. And that's an authorization question. And for that, we have a standard called Alpha. Anybody recognize all of those? Okay, good. Learning is happening. That's excellent. So if you have questions on any of those, jot those down. We can take those at the end, but for right now, let's talk a little bit about OAuth. OAuth 2 is a protocol of protocols. It's being used as the basis for creating other protocols and other standards. An example of that would be OpenID Connect. Other examples would be HART, which is a profile for the healthcare industry, and UMA, and that's for managing access and delegating access to others in a more sophisticated way than is often done with just plain old OAuth. So really, OAuth is solving some important problems here, like delegated access, which I mentioned, but also reducing password sharing. So in order to let someone else do something on your behalf, you don't have to give them your password anymore. We can use the protocols and the message exchanges defined in the OAuth standard to allow us to allow others to do things for us without giving them this sort of God token or API key that we talked about. And this allows us to revoke access in a more fine-grained way. So I can revoke your access, but not necessarily your access. Okay? So OAuth is really solving some important problems, and to understand how that is, let's start to unpack it. We're going to dig pretty deep into it this morning, and where it starts is by understanding the actors that are involved in OAuth. We have what's called a resource owner, which is sort of a fancy standards name for just a user. And it can be other things, but usually it's always a user. And then we have a client, which is really just the application that's doing something on your behalf. So it could be a website, could be a mobile app, could be a desktop application, it could be a headless server. And then finally we have the resource server, another fancy name for just the API, the thing that's actually serving up the resource. To the end user, all of this OAuth stuff that we're going to dig into today is actually super simple, thankfully. It looks like this, those two screens, and sometimes like that. So in the first screen, you have some sort of button, and it will usually say login. I'll say authorize or delegate, but it will usually just say like, you know, get into the app, do stuff. And of course, before you can do stuff in the app, we need to know who you are. So there's some sort of authentication. You could take a username and password, but it could be any sort of authentication. OAuth itself doesn't define and stipulate like you must log in this way. It just says, in some cases, you absolutely must log in, by hook or by crook, however you want, but you got to. So this screen will look differently. This could be like Norwegian Bank ID or something. Finally, you log in, and then if you're accessing a API that is not provided by the app, like the same vendor, the same manufacturer, company, you probably will see something like this. Are you really sure you want this person to do something with your data? Or not person, this application to do something with your data? So you might have to consent or agree that that's something you want to have done on your behalf. If you're like an employee of an organization that's providing an app and an API, You might have already consented to that when you signed your employment agreement. When you signed up for a bank account, you may have already agreed to their terms of service. So the bank app doesn't need to ask you, should you be able to use the bank API? That's sort of silly. So this screen, very often you won't see. Is it okay with the volume? Great. Okay, so this is very simple for the user, which is great, but behind the scenes, what's cooking? So first of all, the client will say to the authorization server, because it needs to call the resource server. So it might call the toaster, and the toaster might say access denied. Like, in order to toast, you need to prove who you are. So the client will go to the authorization server and say, I'd like to get an access token. And to do that, it will show some sort of that screen in the previous slide. Who are you? And as I said before, that can be anything you can dream up. It could be Morse code. Once you're satisfied with who the user is, then the authorization server in some flows of OAuth will issue a one-time access token or a one-time access code. And then the client will redeem that code by calling back to the authorization server. So why would it do this flip-flopping? And this one, this call here, this is going on the front channel in the browser. So in a redirect. So then you get that code on the front channel, and then you do this call on the back channel, like a direct server-to-server call from the client's web server into the authorization server. And with that one-time code, you also have the credentials of the client. So now what's super cool is the user was authenticated and the client was authenticated. So we know who each of those two entities are. And now we issue an access token. And in this access token is all sorts of information, not only about the user, but also the client, the application, what the user allowed that client to do on their behalf, how long that token should live for, how long the consent or delegation that happened up here should be good for. So we've got a ton of information associated with that that's sort of way better than API keys already. Then we toast our toast by calling the API. And this access token travels in either the query string or in the HTTP header. This is defined by a different OAuth specification. But how it's done is normalized. Depending on the type of token, we might make an online call to the authorization server to say, is this token any good? Is this valid? Did you issue this? Can I trust its contents? And then the response to that will have the necessary information about the user, the client, the delegation, and the resource server will make its authorization decision and decide if it should serve up that data. Okay? So that's called the code flow. Maybe take a note of that. That's a kind of flow in OAuth. There are probably about 6 or so pretty common ones, and even more that are not common, all that are standardized. And so that's a very common one. As we talked about in that screen that I said was sometimes optional, the thing that you're consenting to or agreeing to allow that other app to do on your behalf are encoded in something called scopes. These are rights or permissions that you as a resource owner are allowing the client to do on your behalf. And just like tokens are not defined in any sort of particular format in OAuth, scopes are also not defined. So you can dream up whatever you'd like a scope to mean. You can create hierarchical scopes, you can create, this sort of thing. And this will allow you to create permissions or rights or things that you want your applications to be able to do on behalf of your users. Okay? The authorization server will issue different kinds of tokens. It will issue a access token, and it might also issue a refresh token. An access token, you can think of it like a session, and you can think of a refresh token like a password. So when you go to a website, you log in, username, password, and then you don't, with every HTTP request, have to re-enter your username and password. Instead, it gives you a temporary session that lasts for a time, and then you can have a more pleasant experience working with that website and not have to be prompted constantly. So the access token is like that. You have this temporary short-lived access token that will allow you to do some things. When that runs out and you need a new access token, you can bootstrap it and get a new access token by using your password or your refresh token. Does that make sense? We also have different profiles of tokens. So we can have what's called a bearer token, or we can have a holder of key token. Another name for a holder of key is proof of possession. And to help you understand the distinction, a bearer token is like cash, and a holder of key token is like a credit card. So if I'm a lucky guy and I walk out of here and I find a 100 kroner bill on the side of the street, I can pick that up and I can go into the coffee shop and get myself an extra coffee, and the barista won't say anything about me finding it on the street. He or she will just take it and give me my coffee. Whereas if I find your credit card on the street as I walk out of here and I go into the coffee shop, I'm going to be asked for some identification to actually prove that that token or that credit card was issued to me. So the idea here is that with holder of key or proof of possession, you're issuing a token to, and then you have a verification to see that the one presenting it really is the one to whom that token was issued. Does that make sense? So in payments, proof of possession, holder of key, this is a very important profile of tokens. There are standards for how to do this as well, so you don't have to invent your own mechanisms for this. In the payments industry, there's some stuff that people have cooked up, and I would highly discourage you from using that. Types of tokens. So one of the big critiques of OAuth 2 was that the token type was not standardized. And this actually turns out to be a really good move from the standards community, because now we can build other profiles and other standards on top of that, and also create more interoperable systems where we might have legacy kinds of tokens like SAML tokens that we need to use within our API without having to break clients or change clients or redeploy them. So with OAuth, you'll commonly see WS security tokens. Of course, the most popular example of those would be SAML tokens. But you can also create your own homegrown tokens. And these are actually the most popular kinds of tokens used in OAuth. And not the Oracle and the SiteMinder stuff, but a reference token, like just a GUID. You'll see some of those in my next session when I show you some examples, where you just make a random number and you use that as your token, a random string. And another very common kind used within OAuth is something called JOTs, or JSON Web Tokens. JSON Web Tokens, pronounced JOT like the English word to write something quickly, are meant to be very lightweight tokens. That's why they're using JSON, so that you don't require an XML processor with namespaces and all that good stuff. Instead, it's just very small, very compact. Every character then can be thrown away, including padding is thrown overboard. And this allows us to pass them in HTTP headers and query strings without exceeding the maximum lengths that browsers and clients will restrain to those. They're similar to SAML tokens if you have that frame of reference, except they're less expressive. There are fewer security options. They're a lot more compact, and they're encoded as JSON, like I mentioned. Okay, so I mentioned that the most common kind of token is a GUID, or just some random string. What happens then is that we need to pass that token around. We don't need to pass any kind of token around, but when we pass a reference token or a GUID, what we're doing is we're passing a pointer to the identity data. So the user and the client, they authenticated themselves, and then we store that in some sort of database at the authorization server, and the authorization server issues that number or that string connected to that identity data, and we pass a reference around to that. The other way of passing tokens is by value, where we have all of the identity data encoded into the token. We might sign that token, we might encrypt that token, but it's all in there. So in the payment industry, super important to be using these reference tokens, because then you're limiting the number of systems who have access to that identity data. And this is important for compliance reasons then, so that you are having fewer systems that need to be audited, that need to say that, you know, we conform to PCI or any of these sort of specifications. It's like those applications don't ever even see the identity information. They just see a pointer to it, and there's no way back from it. Oh, it's all kept on the server. Okay, so this is highly preferred anytime you're on the big bad internet or outside of your network or wanting in places that you don't want to have conforming to certain standards or regulation. Another nice thing about reference tokens that makes them so popular is that the client applications, like the front-end mobile app, I mean, they'll often take those tokens apart and start to look inside them and say, ooh, here's shoe size, I can put that in my UI, and here's hair color, and I can use that in my UI. And all of a sudden, this token that's really meant for the API has this dependency on the mobile app or the web app front end. And if you change what's in your token that your API needs, all of a sudden you need to redeploy your Android app and get Apple's approval to update your iOS app. So very important to keep that identity data as a reference for as long as possible. So I mentioned at the beginning that, okay, we'll just use OAuth, problem solved. At least we're not using API keys. But what we need to make sure is that we don't have one hammer in our tool belt and think everything's a nail. OAuth is part of the solution, that comprehensive system that I was talking about. And we use OAuth for when it's most appropriate. And OAuth is not for authentication. As I told you, the standard doesn't even say how to authenticate. It tells you in some cases you must authenticate, but it doesn't say how. So how can we possibly use a protocol that doesn't even tell us anything about authentication for authentication? It's also not for federation. Federation is kind of a fluffy word. Again, it just means, figure out who somebody is in one security domain and reuse it in another security domain. So if it's not for authentication, it's also not for propagating that answer across those domains. That's other standards for that. We need identity data to do that, and OAuth has none of that. It's not really for authorization. That's a controversial statement, one that I will stand by with all conviction. It's for delegated access. What do I mean by it not being for authorization? So imagine you're a business owner and you hire an assistant to help you with managing the finances of the company. And you say to that assistant, you can take money out of the company account. And then the assistant goes down to the bank and says, I'd like to take out 10,000 kroner. The banker is going to say, well, you're not allowed, you're not authorized. And the assistant might say, what? I was told by the boss that I could. Yeah, but you didn't sign the right paperwork, the boss didn't sign the right paperwork, access denied. So the banker is sort of like the resource server, the API, where it's making the final decision about whether or not that consumer, that client, can withdraw money. So it's not really about authorizing that application or that client to do certain things. It's about delegating rights to it, just like the business owner delegates rights to the assistant. Does that distinction make sense? So it's also not for federation, and I said at the beginning in our stack we have a protocol for solving that, and that's OpenID Connect. So what OpenID Connect does is it takes OAuth and all of the sort of primitives or atomics and the musts and the shoulds and the recommendeds and the standard, and then adds other stuff on top of that and says, here, you must do this, and we'll also do like this. And what happens is we build this identity layer on top of OAuth for actually taking the information about the user and relaying that across security boundaries, and also giving the client now a view into who actually authenticated. So after you have proven who you are, the application, the client, gets its own token, its own representation. So it doesn't need to sneak into that token that's meant for the API. Instead, it can use its own token, which is called an ID token. And if that's not enough, then it has an access token for an API, and one of those is a standard API called user info. So it can call into the user info endpoint provided by the OAuth server, now an OpenID Connect server, and say, could I get some more information about the user? And that API is designed to look at that token and say, well, yes, you can, but the user didn't allow you to see their email, so I'll just not include that in the response. So it's giving the client now information about the user and an API to get even more. By building it on top of OAuth 2, it's really meant for being mobile friendly and working in that sort of environment. To see how this works briefly, because I'm running out of time, that same code flow we talked about before will start to the authorization server, but now we'll include an additional scope, which is OpenID, and that will click the OAuth server into OpenID Connect mode. So usually when you deploy an OpenID Connect server, you're also deploying an OAuth authorization server. Back comes the code as before. Now we redeem this code to the OpenID Connect provider. We get an access token and the ID token. So now the client can see hair color blonde, shoe size 44, all this stuff, and actually use that. It will check that that ID token is for it if it's a really compliant client. And it might use that access token that it got to get that additional user information from the OpenID Connect provider. So now we'll have that back. So the ID token, as I said, is meant for the client, and this will give you information about the user, how they logged in, when they logged in, and this expiration time around that ID token can be helpful for bootstrapping a session at the application. So then it's actually the security system that's in charge of specifying how long sessions should be used for. That user info endpoint that I mentioned, it allows for user discovery, but it also allows for token issuance. So you can do some pretty creative things with that user info if you use it for token issuance. Right, so you authenticate with an access token and bearer token according to RFC 6750, and the output of that is going to depend on the authorized scopes, as I mentioned. So now I have an example, but I'm already up to 27 minutes, so you tell me. Is it okay? Yep. You can give me the cane if you want to. Pull me off. So how do you apply this to microservices? So we're talking about APIs, and we're going to be doing all of these different microservices that are going to be doing one thing and one thing only, right? There's no way that we can take that reference token and call out every single time to that authorization server. That's not microservices. So how do we avoid that? We want to take that reference token and we want to call to those microservices, but we need to do a translation, first of all, not only for performance reasons and payments. I mean, every millisecond counts. But we also want to do it so that we can get something that the microservices can use offline without making any connection back to the authorization server. So typically you'll have some sort of API firewall, reverse proxy, microservice router like Zool or something like that that's going to catch the call. It's going to have that reference token in the header. It's going to make the sideways call to the authorization server and switch it from a GUID by reference token to a by value token, and then pass that into the network of microservices. So now the microservice just needs to take the public key of the authorization server and check the signature on that without making any sort of network communication. Okay. Finally, some additional resources. Snap a quick picture. Basically, NordicAPIs.com with some little bit.lys. But if you go to NordicAPIs.com, you'll see this API Insights /security. There's lots of videos there. There's entire ebooks. All of the security-related blogs are there. So it's a great sort of hopping off point to a bunch of other resources, which you have here in these short links. I would be remiss not to mention that our product, Security Identity Server, does all of what I said plus way, way, way more, and it's super awesome, and I would love to tell you all about it. It's the most killer OAuth and OpenID Connect server in the world. Not biased, but it's true. So in summary, briefly, API security, it's much, much more than API keys. Don't use API keys. Do something better. OAuth is part of the solution, but not the whole thing. Some OAuth fundamentals, including token types, profiles, uses of tokens, and then how OpenID Connect is built on top of OAuth. So after the break, we'll dive into that and look at some more details. Thank you all very much.